Welcome to Kaiju Mathematics. Today I will be looking at this wild integral I stumbled on the other day. So I was just working on some integrals the other night, just for leisurely fun, and I came across this integral, and it was just very interesting to me. Just this whole visual, and it's very intimidating, to be completely honest with you. Just where do you go with this? And some interesting things happened. So you want to use U-Substitution. When I start my U-Substitution on this integral, that's kind of the first challenge of just seeing what am I going to set U equal to the square root of x, U equal to 1 minus the square root of x, like what is U going to equal to? So you want to set U equal to this inside portion, so I'm going to say 1 minus x to the 1/2. Get your du. Du is going to equal negative 1/2 x to the negative 1/2 dx. So in this current form, not a ton of help. In this current form, it's not extremely helpful, but if we just manipulate this a little bit, so I'm going to rewrite this as negative 1 over 2x to the 1/2 dx, like that. What I can do then is I could at least substitute out dx for something, and then we can maybe try to work some things around here. So let's multiply both sides by negative 2x to the 1/2. So I'm going to multiply this side by negative 2x to the 1/2, and I'm multiplying by negative because this is negative. Multiplying by 2 because this 2 is in the denominator. Multiplying by x to the 1/2 because this is the denominator. So I'm multiplying both sides by that. So I'm going to end up with negative 2x to the 1/2 equals dx. So what I'll do now, just to see where I'm at with this, is I'll substitute it back in and just replace some things. So I'm going to have the integral of u to the 1/2, because I replaced this whole statement with u. 1 minus the square root of x, and that's being raised to the 1/2 because all of this is underneath the square root, times, and then I'm replacing dx with that negative 2x to the 1/2. So it's going to be times negative 2, oops, I forgot the du here, times negative 2x to the 1/2 du. Getting closer. I have a constant here, so I'm going to factor that out at some point, just kind of put it on the outside of negative 2 times the integral of this. But this is a problem. I have a u, I have an x, I have a du. I want this in terms of u. What I have to do then is I have to go back to my original u and rework this a little bit. I'm going to move me over here. So I'm going to work with my u statement here. And I'm going to solve for x. So I'm going to replace x with a statement in terms of u. So I'm going to subtract 1. So I'm going to have u minus 1 equals negative x to the 1/2. It's negative, so let's flip that. X to the 1/2 equals 1 minus u. X to the 1/2 equals 1 minus u. I'm going to take... I'm going to square both sides. I almost said square root, but I'm going to square both sides because it's a square root already. So I'm squaring both sides, so I'm left with x equals 1 minus u squared. So before you freak out, and you're like, oh, now I have to square this? I'm going to have to do 1 minus u times 1 minus u. Look what happens, though. Let me fix this up. Look what happens. I'm replacing x with 1 minus u squared. So when I substitute that in, x is being raised to the 1/2. What does a 1/2 and a square do with each other? They pretty much work together, and all I'm going to end up with is just 1 minus u. The square root of a square is that value. So all I'm going to have now is, let me get a new color here. Let's go with this. So I'm going to have the integral of u to the 1/2 times negative 2 times, and I'm going to show this here. So I'm going to have 1 minus u squared to the 1/2, which is really just 1 minus u. So I'm going to have negative 2 times 1 minus u du. Still not out of the woods yet. I'm going to take out that -2. I'm going to rewrite this as u to the 1/2 times 1 minus u du. And then now we start to condense a little bit and it starts to come together. So I'm going to multiply that. So -2 integral u to the 1/2, u to the 1/2 times 1, u to the 1/2, u to the 1/2 times u to the first, 1/2 plus 1, 2, so 3/2. So minus u to the 3/2 du. Let's take that to a new page, but now it's just integration from here. So this is going to become, let me actually just copy this over. So I don't want to have to try to write small here. This is 3/2. Okay, so -2 times u to the 1/2 is going to be plus 1 over 1/2 plus 1. U to the 1/2 plus 1 is going to be 3/2, which is going to be 2/3. So 2/3 u to the 3/2 minus, and then this is going to be plus 1 over 3/2 plus 1. So 2. So 3 plus 2 is 5. So this is going to be 2/5 u to the 5/2. Let me tack on that plus c. Now we have to put our original u back in while also multiplying by -2. Our original u is 1 minus the square root of x. So I'm going to be multiplying all of this by -2. So -4 over 3. And then what did we say our u was? 1 minus the square root of x. So 1 minus the square root of x to the 3/2. -2 times a -2 is a positive 4 all over 5. Our u was 1 minus the square root of x to the 5/2 plus c. Wild stuff. Really, really good integral there. A lot of tricks. A lot of tricks going on. And even the integration portion wasn't super easy to do. It was just a lot of fraction work. But the real trick to this question was this, like this whole concept of solving for x and then substituting that in. If you like this content and you want more math and calcudokus in your life, please hit that subscribe button. And thank you for watching.